Tonight's lecture is primarily on masonry. So masonry units are constructed of various different materials: clay, concrete, mud, glass, etc., bonded together using mortar. So the typical definition for masonry are blocks of material that are bonded together. So you've got your horizontal joints called bed joints. So these mortar joints under the brick here, bed joints, and vertical joints called perpends. Typical masonry units. So clay bricks win by and large is the most commonly used masonry unit. And this size is important. It's 110 wide by 230 long by 76 millimeters high. The reason that this is particularly important, and it's important for all, well, it's an important consideration for all types of cladding, very important consideration for designers. The dimensions of your brickwork will determine where you place your windows, and also it determines the size of the windows that are used and produced as well. So your various window and door manufacturers, of course, they produce their windows as per brickwork dimensions, but the placement of your windows on the wall, exactly where you place them, as a designer, you should do that in accordance with the brickwork dimensions. So if we want to set a window in, say 4 bricks from the edge of the building, we've got 4 bricks width plus 3 mortar gaps. So there are various, so it's easy enough to find tables on the internet for your brickwork dimensions. In fact, I'll quickly just have a look now. So we go. Go straight to images, grab a table, grab standard brickwork dimensions. Oh, with interest, right. Yeah, so bring it up. All that clear? No. Down, see if we can find another fairly clear table, brickwork dimensions. Same one. Is it the same one? Is it Pinterest again? That's right.
Where are you heading? Just think about underneath this.
Underneath?
The fire.
See if we can cruise in there a bit. So, actually, well, so not a good example. We've got odd size bricks. So, yeah, spend a little bit more time searching on the net. But basically, you can find tables like this that correspond to your standard size bricks that show you. So your horizontal joint, so we're 6 bricks in, plus joint is 1360, etc. And so the placement of your windows should be done, or windows or any opening in the brickwork should be done in accordance to those brickwork dimensions.
Even your wall lengths.
And even your wall lengths, yeah, exactly.
You don't want to cut bricks.
Yeah.
Somebody be split.
So our dimensions of our brickwork is very important for the design of the building, and this also relates to any form of cladding or walling that you use. Even if you use concrete block walling, you have other dimensions to work with. So typically your large concrete blocks are 390 long by 190 high, and they come in various different widths of 140, 90, 190, etc. So that 390 long plus a 10mm mortar gap gives you 400 long block. But it's also an important consideration for even some sheet metal products for your walling. Some of the flat pan, high ribbed profiles require that you have your windows joining partway through the flat pan and not at the ribs. So it's an important consideration for all types of cladding. Other types of masonry beyond our standard clay brick, concrete bricks and blocks, natural stone, autoclaved aerated concrete, calcium silicate bricks, and glass fibre reinforced plaster. Not that these two are particularly common in Australia, or plastic bricks. And the actual PEM blocks you don't really see being used much either. So properties of clay bricks: tests to carry out on bricks to ensure that the limits set for dimension tolerances, efflorescence, transverse strength and compressive strength are adhered to. So efflorescence, that is the taking up or the wicking of the salts in the clay, and it's not a problem in and of itself, but it can be an aesthetic issue. So it's that sort of white, furry deposits you sometimes see on brickwork or concrete. Yeah, it's different than salt damp. So yeah, I guess same process, same sort of thing, but salt damp is where you've got an ongoing problem of efflorescence where it continuously wicks moisture and you get depositing of salts on the surface of masonry or or concrete, and the salt deposits start forming crystals and start wedging out little bits of sand or little bits of stone also. And so the salt actually starts breaking apart your walls. Efflorescence is just simply the initial depositing of those dissolved salts. So yeah, so you can get efflorescence where you don't actually have any moisture issues. The tests are also conducted for characteristic expansion, initial rate of absorption, and water absorption properties. Bricks, of course, have a great fire resistance. Their size enables easy handling and placement in walls and can be easily adapted to small scale, large scale structures. And modern any form of brick, but bricks can have a pleasing appearance and texture. But typically, your modern glazed bricks quite popular, can be popular with architects. Yeah. Yes. So the moulding of bricks, the raw material is dug from pits, crushed, ground and screened to reduce it to a fine consistency. Then it's tempered with water to produce a plastic clay ready to form into its shape. And then as in this situation, well, they're fired and then glazed and then refired to have a glazing on the outside. So the length of the clay brick, well, there are dimensional tolerances for clay bricks, and it should be not less than 1.5 times the width, nor more than 390 millimetres long. The height is to be no more than 70% of the length, with the gross volume of the unit not exceeding 0.004 cubic metres. So our standard size, 230 long by 110 wide by 76 high. However, for a while there, in the late 70s through into the 80s, modular bricks were being used in construction. So they're 290 long by 90 wide and 90 high. To the trained eye, they're fairly easy to spot. I don't know if anybody else has ever spotted, just longer looking bricks, or you live in one. Yeah, it's so it was it was an idea of creating I guess bricks to metric dimensions, but it went out of flavour fairly quickly. And then also, not that I've actually seen any of these buildings, but jumbo bricks of 390 long by 110 wide by 90 high. However, you typically get your cement blocks in these dimensions, or concrete blocks, sorry, in those dimensions. Some terminology in regards to brick walls. So the corners of the brick are known as the arras, and it was a thing in the 1980s to have a bit more rustic looking bricks, so tumbled arras bricks. So when they're soft, they're tumbled and slightly deformed. Get these softer arrases. These are sharp arras bricks. This face of the brick is known as the header, and this face of the brick is known as the stretcher, and we'll go into that a little bit later on as to why that is important. So these are our perpend joints, our bed joint down here. At the base of the wall, we have weep holes. So that's to allow any moisture that gets in between the two leaves of brickwork, or between the leaf of brickwork and the frame, to seep out. Our corner blocks are known as coins, and typically we'll, on many brick veneer houses that have coins, we just carry the brickwork around the corner, but then put on red coins afterwards to give that appearance of solid coins. Particularly for subfloors and or where we have a situation of a suspended floor, we have vent bricks. Given the example here of a half bond. So that's where we have our perpend joint directly above the centre of the brick. We'll go into different types of bonds there, and here we've got a breaking back. So that's where you have a sloped end to the leaf of brickwork. Also, any like a single brick wall is known as a leaf of brickwork. And so for cavity brick construction, we have two leaves of brickwork joined together with steel ties. And for double brick construction, we have two leaves of brickwork that share a header bricks in common. Other types of masonry units, we've got adobe or mud bricks. So these are non-fired, non-fired clay essentially. There are also rammed earth bricks, so or compressed earth or compressed soil blocks. Rammed earth in its more traditional form, but this is not actually a form. Essentially, it's not a form of masonry. It's been thrown into or put into these slides because it behaves a lot like masonry, but it doesn't actually consist of separate units bonded together with mortar joints. And essentially, straw bale is a form of masonry, even though it doesn't behave like other forms of masonry, but it is individual units put together. These are hollow concrete blocks, or Besser blocks, and Hebel blocks. Typically, with your concrete blocks, well, one possibility is to core fill the blocks. So they're used essentially as a concrete formwork for the core filling. And in that situation, we have vertical reinforcing with a cog, or in this situation there, they've got a vertical reinforcement with a cog on the end. I assume to bond into a concrete slab to be cast on the top. You also have horizontal reinforcing to help with any of the expansion of soil underneath, but also it assists to reduce shrinkage between the blocks. Shrinkage in concrete blocks shrinkage in new concrete blocks can be a significant issue. I've seen a newly built house that used the smaller concrete bricks with mortar, and the shrinkage was enough to open up the brick control joints significantly. They were about 20 mils wide when I inspected it when it was several weeks old, because as concrete loses its moisture, it shrinks slightly, and as mortar loses its moisture, it shrinks slightly. In the situation with clay bricks, so clay bricks with mortar, your mortar will shrink slightly, but your clay bricks will take up some of that moisture and they'll expand slightly. So much of your expansion and contraction is equalised in a clay brick wall, but in a cement or concrete block wall, if those concrete blocks aren't adequately cured, you can have significant contraction over a wall. So various different bonds. So typically for all of our brick veneer, we see this stretcher bond. So that, because with brick veneer, we're dealing with a single leaf of brickwork. We have our steel or timber frame, then our approximately 40mm cavity, and then our external leaf brickwork. And the stretcher bond is quick and easy to lay and doesn't require any cutting of bricks except at ends and openings. For double brick walls, so that's where we have two leaves of bricks bonded together with common bricks. We have these other types of bonds, so such as English bond and Flemish bond. That's where, if we were to look at that in plan, well, let's look at Flemish bond in plan view. We would have two stretchers like this, and then a header between the two, and then two stretchers again, like that, and a header. So our headers are bonding our two leaves of brickwork together, creating what is double brick. And I'll just do a diagrammatic representation of the difference between double bricks and cavity brick construction. So that's one leaf of brickwork, that's another leaf of brickwork, and then we have our cavity in between. And that cavity may be filled with insulation also. So that's an important distinction. A lot of people refer to cavity brickwork as double brick. They say I've got a double brick home, but more than likely they've actually got a cavity brick home.
What's better insulation-wise, the double brick or the cavity brick?
Well, yeah, double brick doesn't allow for any insulation,
Okay.
which is an issue with meeting the requirements of the National Construction Code. I can't think of what the R value of bricks are off the top of my head, but it's basically none, or yeah. And so you have insulative requirements for, so we're in climate zone 5. I think it's getting up to about R2 for your walls, or R1.8 I think. And so you've got to get that insulation in there somehow to your external walls to meet the requirements of the National Construction Code for climate zone 5. So with our double brick there, yes, it's got fantastic thermal mass, but you've got to get some insulation onto that somehow. Now you might do that with a, say like a compressed straw panel or something on the inside that will give you your R value, or you might want to, use a foam when you foam they expanded polystyrene foam panels on the outside with the mesh, and then render that. So you can use your double brick work as thermal mass inside your house and still provide insulation on the outside. But you've got to get your insulation onto there somehow. Whereas with the cavity brick, and I'll show you in the slides further on, you can fit your insulation in between here. And that's typically done with wall ties with little wheels on there to hold it back. Yes, holds it to the internal leaf, so it allows moisture to seep down the inside face of the external leaf and exit without going into your insulation.
Do they still build double brick?
Very rarely.
No, yeah.
The only time I've seen is when they're doing an extension of something like my house.
Yeah.
Just maybe carrying the rest of it. But even then, time still brick nails.
Yeah. Pretty much the only scenario I see people doing it. Well, I just don't see people doing it. But the only scenario I can imagine is with the reinstatement work of historic buildings.
Yeah.
So they're. Yeah.
Builders are very reluctant to kind of do it.
Yeah, well, it's. I think it is a dying art or a dying skill set for doing brick walls with shared bricks.
Yeah, the insulation on crack houses as well, much easier. Use it, paint glass the way you want to use.
Yeah.
Yeah, you got your minimum for those like 2.5, they fit the wall. Easy.
But yeah, that double brick. There's a lot of that in the Netherlands. There's.
We got our house rebuilt because it burned down, and then it used to be double brick, but the builders didn't want to do double brick, and they said because they need to do extra things. I forgot what it was, but there's more chance of cracking and stuff as well.
Right.
So
yeah.
I don't know the reasons why, but it was basically impossible.
With a brick that way up past the inside, and the expansion and subtraction of the bricks might cause that past to crack on shit. I know a lot of grandparents have got a double brick house, they just cracks all over.
Yeah. So I'm not sure what it was, but it's interesting hearing it. All things now.
Yeah, so at a firm I used to work for, we had an extension done to the office there, and that was all done in cavity brick to tie in with the rest of the construction of the building, and that had your traditional plaster render, and it's fine if it's done properly. You can engineer your slabs, of course, to take all that load, but when you're going with either cavity brick or double brick construction, you have to be cognizant that there is a significant amount more weight that you're carrying there, and that might have been the issue with your builders. That I don't know, did you have the floor slab replaced as well?
Eventually we did get everything.
Right, so
just
clean slate. Yeah. All right. So if they had to, if they were, say you had a scenario where they were using the same footings, typically you probably wouldn't be able to use those same footings again to do double brick or your cavity masonry. Or if they're putting in new footings, possibly it's going to be far too expensive to do the double brick or the cavity brick. Because of the cost of labour to produce, but also the cost of footings. So here's various different different bonds of brickwork. So mortar, it provides the cushioning and holds the bricks apart in the wall. It shouldn't be seen as glue for gluing bricks together. Basically, what it does, it forms around the bricks, and through your process of say there's saw movement or so, and there's tension placed or compression placed on the wall, it holds the bricks apart essentially. So it's a solid cushion between your blocks or your bricks. Mortar mixers must comply with Australian standard 3700. That's Australian standard for masonry walling. General purpose mortar. So one is a 6. So 1 cement, 1 lime to 6 sand. Mixing process is called batching, carried out by volume. I haven't actually watched brickies mix mortar on site. Don't know if you ever seen them using gauge boxes or also using shovels, but it's basically it's like baking a cake or so. Some people do it by the recipe, others know their consistency, know exactly what they're wanting to achieve. Bed joints and perpends should be 10 millimeters in width. Joints are formed as work progresses. So the joints are formed by slapping the mortar on and tapping the bricks into place to get that 10 millimeter width. If a designer has not been very adherent to brickwork dimensions, what brickies can sometimes do is expand or contract that perpend joint a little bit to stretch the length of the brickwork to get it to meet windows, but they're not very happy about doing that either. Best course of action is design in regards to brickwork dimensions. So the process of forming a tool joint after the work is completed is called pointing. So first of all, the mortar is slapped on and bricks are tapped into place, and then the excess mortar is scraped away. But to give a good aesthetic and also some weather protection, the mortar between the blocks is scraped away a small amount, and got it on the next slide here. So these are our various different ways of pointing brickwork. So that's your standard. That's what you'll see around. Either raked or concave. They're fairly easy to produce, but there are other forms of pointing as well. So tool joints are used to enhance durability of the joint and its appearance. When we have double brick or cavity brick construction, typically we'll also have single leaf internal walls. If we have single leaf external walls or single leaf load bearing walls, typically we have what are called engaged piers. So these are typically used where we have a garage. So we might even have a brick veneer house. So we've got a timber frame, but then within the garage, and you see it sometimes, where you've got your single leaf of brickwork. So this is our single leaf brickwork like this, and then little sections like this that protrude out, and the wall continues. Has everybody seen that in carports, etc.? So they're what are called engaged piers. And that basically provides a greater dimension to the wall to give it stability. Because if we carry that through as single leaf masonry all the way, then there's little to resist the overturning of our single leaf masonry. So single leaf masonry has to be tied into other walls or have engaged piers. And the way those engaged piers are constructed are like our other forms of double brick bonds. So English bond, for example, where we have, to start off, we'd have two stretches like this, and then we'll have, two headers, for example, or they might be 390 wide. So we've got an extra brick in there, we've got a header and two stretches, for example. But for it to be an engaged pier, it has to share common bricks with the wall itself. Something I have seen in some single leaf masonry walls are what appears to be engaged piers, but are essentially non-engaged piers, where you've just got brickwork stacked up like that, and it's only a mortar joint between the two. That really doesn't serve the purpose at all, as those two leaves can separate easily. As mentioned before, hollow block walls can be can be reinforced, well, can be core filled and reinforced vertically through the cavity. With our brick veneer walls, so we have our framing, and then we have a cavity between that framing, somewhere between 25 or between 25 and 60 millimeters, but typically it's 40 millimeter gap between your framing and the external leaf of brickwork. Stud work, so that's our vertical members, is fixed to the masonry by wire ties at, well, this is meant to read 600 centres, unless it's around an opening, and all the wire ties have to be at 300 centres. The weep hole is allowed for at every fourth brick to allow moisture to exit the cavity. And for suspended floors, for ventilation under suspended floors, air vents are at 1 metre intervals. So your vented blocks or vented bricks are at 1 metre intervals.
How does reverse brick veneer work?
Reverse brick veneer, well, basically, essentially it's like the reverse of that. So this is our external cladding. So reverse brick veneer it tends to be a little bit more expensive way to produce a wall, but the benefits of it are that you get the thermal mass of the brickwork inside the house. So it's about creating a good thermal flywheel, because bricks are not very good insulators, but they are fantastic at storing heat. So your thermal mass in here. So you get your thermal mass inside the building, then you have your insulation between your stud work, and then you have some form of cladding on the outside.
So your cladding would have to be something different.
Yes, yeah. So we can't use plasterboard on the outside, but we could use, for example, fibre cement sheet or pretty much any of those, or weatherboard, foam cladding with render. We could use Hebel if we wanted, thatch or straw bale, hempcrete. Well, actually, no, you probably wouldn't use hempcrete from the outside. You're getting very heavy. But yes, so or custom or corrugated steel sheeting on the outside.
So can blue board be used inside the house, like in the internal wall?
I can't say whether it can or cannot be, whether there's any rules against it, but I know there's a reason why you wouldn't. And the reason you wouldn't is that it doesn't take up any moisture. And inside houses, you get moisture from various different activities, like you're boiling the kettle, that sort of thing, talking. Like you put moisture into the air, or you have, say, very warm, moist air come into the house, and then it gets cold at night, and moisture condenses. And your plasterboard or plaster linings inside the house take up that moisture, and they regulate the moisture within the room. If you were to use blue board as in internal linings, you end up getting moisture collecting on your internal linings, and you get mold, etc. happening as a result of that. So that's typically why we use some form of plaster, be it gypsum plaster or so, for internal linings. So in some, like I've seen in the art gallery over in Melbourne, the National Gallery there, they've got fibre cement sheeting used for internal walls. I've seen it some places on the internet where people have chosen to use plywood for their internal walls, etc. But I think typically it's unless it's a fairly well ventilated space, it's not a good idea.
Wet areas like your bathrooms and stuff like that.
Well that's
But then you've got your extractor and biology as well.
Exactly, yeah. So that's designed as a ventilated space, and it's designed as a wet area. So it's an area that's designed to deal with moisture, and you clean it regularly. So because you're expecting that moisture.
No, you use the blue board or something similar, which is like a blue board you can't tile on. It's got a different property, whereas blue board you can tile on. And vice versa, you can't render on a bit of board, so you can't use that externally. You can use it as sealing and stuff like that, but yeah, I use Google and Ajax for render that for guiding
Here's a detail here with the terminology on brick veneer. So we've got our plasterboard, our surface cavity, our insulation that goes into that surface cavity, then the protective, so the builder's wrap going on the outside of the timber frame, and typically a good idea is to have a breathable form of wrap as well to allow some of the moisture that's taken up by your plasterboard to exit the wall. Then the wall ties, which are nailed back into our timber stud, and they go into the mortar bed joints of the blockwork or brickwork. Well, this is 9mm OSB, so that's a form of bracing. So that's a form of sheet bracing as opposed to the metal strap bracing. And that's our cavity there. Possibly this is American detail. So that's our bottom plate there. What's that?
That's thick bracing.
That's thick. Oh yeah, 9mm. Yeah, I guess that is very thick bracing as well.
I use 6mm in Australia.
Yeah. And also what they haven't included in here is flashing. So flashing, damp-proof course that goes under the brickwork and it is carried 150mm up the studs to ensure that any water which makes its way down the internal face of that brickwork exits through the weep holes. So here's an example of our brick ties. So in this example, they're screwed into the timber studs and they're laid with the blockwork to go into the bed joints. So cavity brick walls or cavity masonry walls. So have a cavity between 35mm and 65mm. Can be reinforced or unreinforced. Cavity ties, like brick veneer, have to be at 600 centitres, and you have to have weep holes to allow the drainage. The way you think about moisture with masonry walls or typically brick walls is that yes, you try to stop its egress, but you try to stop moisture getting into the wall. But basically, it should always be constructed in a way that gets water out, because you can fairly much guarantee that there will be small amounts of water that make their way into the walling somehow. And it's about making that water exit. What's that? Yeah, that's really good example of well, yeah, they're going to render over that, I think. Yeah, so good example of some very poor brickwork. So to resist lateral loads, provide intersecting walls and limit length of walls at return ends. And you need good bonds between bricks and mortar, so not this type of business. Provide lateral supports. So that can be our engaged piers. Rafter tie downs provide lateral restraint. So that's where you have your raft. So with cavity brick walls, we have to tie our rafters down into the wall somehow, or if we fix our rafters to a what do we call it, a brickwork pitching plate. A brickwork pitching plate, yeah. So if we tie our rafters down to a brickwork pitching plate, we have to tie that pitching plate down to the wall somehow, and that's typically done with a 10mm rod that goes between the two leaves of brickwork and a steel strap that wraps around that 10mm rod. So for N1 and N2, for the steel sheet roofs, need a 30 by 0.8 steel strap over rafters at every 1200 centres. So that's at every rafter. And fits into 10mm rods built into the brickwork at least 900mm down from the top of the wall. That can also, so typically your rods are cast in when you're making or when you're laying the bricks, but it can also be done retrospectively fairly easily as well. So you drill through the mortar and then you tap your rod in, and then you get your galv strap, make a loop in it, sort of 900 down, feed that into the wall and hook up around your rod, and then tie your rafter down. This is a detail with the straps. I think it's a detail with the straps nailed into the, like using masonry nails into the wall. We've hired by 1mm galv steel straps, no more than 2 centres, corresponding with truss raft applications built into the masonry inner leaf. So the straps built into the masonry inner leaf. But that's.
Is that unusual for the external wall that holds the load on a cavity brick?
Typically I think typically the load is shared between the two leaves of brickwork, and also your uplift is shared between the two leaves of brickwork.
But your roof is.
In this scenario, yeah,
in this scenario, it's on the internal. I thought it was on the external. Right. It's not the expert.
Yeah.
The pitching one on.
What's that?
Whichever one they want it on.
Yeah.
If you're the only one's the load bearing one, then they'll put it on the road.
During the load bearing one's the external.
Up to the
Builder, up to the truss
up to
designer.
the architect, what they decide they want to do. Could be what's existing there already. They could already have that on the inside, so just maintain the same, keep the same wall line.
Yeah, it's something I haven't done a lot of work on.
Right, it's just work that I have done.
Yeah, you've seen your rafters typically pitched off the external brickwork.
Done extension and done probably existing on the outside.
Yeah. But wall ties provide strength and must be protected from corrosion, as per the Australian Standard 3700 for masonry. I've seen it previously where wall ties have been welded to universal beams, and that weld not treated correctly and rusted out, and the whole masonry wall has fallen over as a result. So the masonry ties, or your steel ties, do provide a lot of strength to that wall. They connect two leaves of masonry, or masonry and timber, or masonry to timber or metal stud, either galvanised or steel wire. Acts to stabilise the masonry leaves and stiffens the wall cavity structure. Embedded 50mm into the mortar joint, must have a minimum of 15mm cover to any surface. So just like our steel work in our slabs, there's minimum cover to the ties. So you don't want the ties going to the external face of the masonry to outside, because then they may corrode and explode that mortar out. Should be installed to prevent moisture breaching the cavity. The way that we do that is to ensure that we don't have our ties sloping back towards the wall frame. So there's our external leaf of brickwork like this, and let's say our timber studs like that. If we go putting wall ties in there like that, that's fairly bad practice, because any bits of water that come down the internal face of the masonry like that and then hit our wall tie can can travel down that wall tie onto our timber frame and then start soaking in or making their presence known in the gyprock there. So if anything, you want that wall tie to slope slightly toward the brickwork. However, wall ties, and I might have some in the box up there, but typically they have a little drip groove in them like that as well. And so if we did get some moisture coming down the face of the brickwork and hanging off that wall tie, it gets to this point here and drips off. So they're designed like that. So yeah, it must have a drip groove or bend and spaced at 600 centimeters. So normally your brick ties are spaced at 600 centimeters, but at any articulation joint or brick control joint, they're spaced at 300 centimeters, and around any opening, they're spaced at 300 centimeters. And here's some example of brick ties. So these brick ties with the small wheels on them are to hold the insulation in place, and that's holding the insulation to the internal wall. So that face of brickwork can have some moisture pass down without affecting the insulation, and also to help that insulation insulate this concrete block wall more effectively. A masonry wall must allow for controlled movement to avoid damage to the building, and the way that is done with brick control joints. So brick control joints, as defined in the BCA, combine both articulation joints and expansion and contraction joints. So as I explained before, expansion characteristics of clay masonry are that the clay masonry expands slightly when it takes the moisture out of the mortar, and your concrete blocks shrink slightly when they take the moisture out of the or when they start to lose moisture. Expansion and contraction can be controlled using joints. So your articulation joints are for any, or basically for any articulation of the building, so for any bending stress, and expansion joints are to allow that shrinkage or expansion of masonry units. And depending on the soil type, they're spaced at, or predominantly at 6 metre centres, but if not 6 metre centres, then at 5 metre centres for more expansive clay soils. The way those brick control joints are created, you use, or you leave a 10 millimetre gap. So your brick control joints are always 10 millimetres to correspond with your width of mortar, and you put a foam backing rod in there, and then a mastic sealant on that foam backing rod. So you must have a joint where you have a change in roof line or a change in story. So what you'll see in these slides are reference to, so we've got here a sealed articulation joint. So articulation joints, so in the National Construction Code, it defines you must have articulation joints at these particular centres. You must also have expansion contraction joints at these particular centres, but the term brick control joint takes in both of those. So typically where you see articulation joint mentioned or expansion joint mentioned, that's what we're talking about, a brick control joint there. So, and you'll see that noted on plans typically as BCJ. What's that?
It's just
Or just CJ, yeah. And it's important for you as designers to put those, to nominate the spacings and the location of those control joints as well. So where we have a change in story, we need to have control joint, and or for example where we have a masonry building and a masonry wall, we can have an unsealed control joint. Where we have any openings greater than 900 millimeters by 900 millimeters, we have to have a control joint either up one side of that opening. So here we have our window, and then we have a control joint from the ground all the way to the feet or to the top of the brickwork. And similarly where we have a door opening as well.
So is that what part of the
That's so the NCC defines control joints. But the Australian Standard 3700 says where they need to be.
and which respects away from the size?
Yes, yeah.
700.
So it must be placed in positions which do not compromise the strength of the structure. The requirements, AS 3700. Opening movement of the joint must not exceed 10 millimeters, and closing movement not to exceed 15 millimeters. Now, unless you're a brickwork engineer, you're not going to know, or you're not going to calculate through the expansion and contraction of your brickwork. Hence, within Australian Standard 3700, it defines where you need to place them in the building, and that's what you need to be wary of.
But is it one of them that the train said?
I
I know you touched on it.
Does everybody know how to look up the Australian standards now in the library?
Yeah.
How to look? Yeah, it's a very important resource to make use of. Over top of control joints, you need to have sliding ties or masonry anchors that still tie that leaf of brickwork together, but allows expansion and contraction. So masonry anchors must be built in at every fourth course for cavity walls. So cavity construction. Yeah. At junction. And so your brick control joints are used at junctions, walls, windows and doors. So a 10 millimeter gap once again. Single skin masonry wall joints must be sealed with a flexible sealant or mastic. So we've designed our house and we've done the floor plan, and then we go around. We go, okay, well we have, a window size here of greater than 900. So we'll put a control joint in there. Or assume this one's the same size window. We'll put one there as well. But we also have these really long runs of masonry. Let's say it's fairly reactive soil, and the width of that is 6.5 meters. We'll have to have a control joint in there somewhere. So typically we'll denote that as being in the middle of the wall, so it can take up our expansion and contraction of our brickwork, and also that's the place that's more likely to open up, where we're going to get some flex in our slab. So if our run of brickwork there was only 4 meters, then we wouldn't need to have an articulation joint, or we might have that articulation for, let's say between this window and the edge was only 4 meters, then we wouldn't need to have an articulation joint. But if we exceed exceed that 5 or 6 metres, depending on the soil type, we need to put in a control joint there.
Is that the designer or the engineer do that?
It's up to the designer. Yeah, oh, the designer
Does
might.
the engineer dictate, oh, yeah, this does dictate. Soil B does the assessment of the soil determined.
So within Australian Standard 3700, it says so it's got your different classifications of expansive soils, and just for moderately reactive, I think, well, for class M soils, it's every 6 metres, and then for extremely or highly reactive, it's 5 metres. But let's say, because I don't know off the top of my head, but you've got it's detailed within the Australian Standard at what spacings they need to be.
But the engineer does the assessment after the sort of plans, and then from the designer. So he's got the plans, and he gives those plans to design his cooling system and his control joint.
It may be, or
That's my experience.
That's your experience.
That's my
experience. That engineers also
Generally,
Yeah.
control joints, because they've got all the information.
Yeah, I guess
they
so.
know the soil type, they
Yeah.
design the cooling to accommodate for it, and then they'll put the control joints in accordance with the plans and the and the soil form and then design.
Yeah.
Will then become one package rather than, and then you can always then relate that back into your plans.
And sure, why not? If the engineer is designing the footings, sure, and take the engineer 5 minutes or something to determine the locations of those.
Because the worst thing to do is that you put them in there.
Yeah, and you don't know what you're doing.
Engineer puts them in somewhere else, and then it becomes a you said, he said confusion.
Yes,
So keep that in mind as well when you work with the engineers.
Oh, certainly, not only brick control joints, but if an engineer specifies anything, go with it, because it's on their their professional indemnity insurance as well. But if you were to specify them yourselves, the way you specify the location of your brick control joints is through the Australian Standard 3700. We've covered all that fairly well. So we've got straight continuous walls and no openings, 6 metre centres, so that's class M soils. At locations where there is a change of wall height greater than 20% change, where walls change thickness, you need a brick control joint. And it's not typical that you have control joints in slabs, but for some buildings you will have control joints or construction joints in slabs. And so wherever you do have a control joint in the slab, you also need to have a control joint in your masonry. Because where you have a control joint in your slab, that's where it's going to crack. That's where it's designed to crack. And so you want your masonry to articulate above that. Or at walls constructed of different materials. Or where you have deep rebates for service pipes. So that's a weakened point in the slab. So we've got service pipes for some reason creating a weakened point in the slab. Not that is a common detail either. So various different expandable wall ties over our control joints. For your concrete block walls, to help counter some of the contraction and the shrinkage, you've got horizontal reinforcement or ladder mesh that can be put in. So steel takes the tensile forces and reduces movement of that wall, so it's providing horizontal reinforcement. So it consists of 2 steel wires, 3 millimeters in diameter, welded in the ladder pattern. placed at 600 centimeters above and below wall openings. So particularly with our brick veneer walling, or with any walling, we want to stop the egress of moisture wicking through the brickwork, but we also want to ensure that any moisture that comes into that wall is sent out of the walls with weep holes. So to do that, we use a damp-proof course. So it's a black embossed polyethylene film that the mortar and the brickwork sits upon. Polythene. Yeah. It's a damp-proof course defined as a continual layer of impervious material placed in a masonry wall between floor and wall to prevent upward or downward migration of moisture. So our DPC stops the moisture travelling between the slab and the bricks, but also acts as a flashing. So we should carry that damp-proof course up to connect onto either our stud-work, or in this situation to the top of the internal slab. And so a flashing is designed as a strip or sleeve of impervious material, so PR, steel, polythene, lead, shaped or dressed to provide a barrier to moisture, or to direct moisture in a certain fashion. Typically within older buildings that were built prior to the invention of damp-proof courses, or if we've got moisture gaining entry into the building for some reason, we can have damp and rising damp. So it can be as a result of defective plumbing, or porous building materials, condensation. So where we have that warm, moist air condensing or getting cold inside the building and depositing moisture. A bridged cavity and cavity walls. So let's say our brick ties are placed incorrectly. Blocked weep holes at the base, or ineffective flashings, damp-proof course. So flashings are typically a very weak point, or poorly designed flashings enable moisture to get into a lot of buildings, typically where you have very low-pitched roofs, and inadequate flashing around penetrations such as chimneys or air conditioners, etc. is a really good source of moisture. But also defective plumbing is a very common one as well.
About the breakdown of PVC. Is
Yeah.
there a lifespan on it? And how? Because you can't replace it.
No, you can't replace it. Yes, you can replace it actually.
Oh.
Yeah.
I know of a builder that forgot to put it in. So somebody had to go and put it in there. So,
How's it possible? You can't lift up the wall.
no, you have to take out a few bricks, put those bricks in, and take it out. So it's a shocking time.
Yeah.
Mm.
So is there a lifespan
Yes.
on it?
I don't know.
Yeah.
That is a really good question though. Yeah.
Unless something breaks it, it's not exposed to it.
Yeah.
Isn't it
Yeah.
plastic?
Yeah,
Well,
Plastic
it is-
glass.
that's right. So it's not,
Yeah.
it's not exposed to the sun or anything.
Yeah. Yeah, and heat.
Yeah.
Yeah. So I think as long as it's sandwiched between your mortar and your slab. Yeah.
It will outlast you.
Yes. But yeah. So breakdown of decomposing environmental and corrosive elements. Yeah, possibly. That's something I haven't actually explored. Is the possibility of that and how it happens, or what is the typical lifespan of a DPC block? But that is a very good point.
It would be knocking down houses.
What's that?
We'd be knocking down houses.
Yes.
It has to be an extraordinary event.
Yes, it would have to be an extraordinary event. Yeah.
And like somebody's trying to repair it's broken.
Yes. Yeah. Yeah. That's more likely the scenario, or initial poor building. So moisture will penetrate through the external wall of the cavity and then typically down the inside face of the wall. Cavity must be clean and have uninterrupted damper course and flashings over doors and windows. So typically what will interrupt the DPC, bits of mortar, also excess dags of mortar must be removed. So when you're doing the brickwork, so excess mortar can fall down the cavity and breach the damper course. So you need to keep the cavity clear during wall construction, either by use of cavity batten board. So, yeah, this is in the slides. I'm not sure this actually happens very often, leaving every brick out as an access to clear cavity during construction, or use of cement bags beneath construction to collect mortar as it drops. What's that? Seen it done, leaving the fifth brick out to clear it. Yeah. Actually, I think I said the same when we had the lecture previously. I think you said that. Yeah. So
I did it at my house.
you did it at your house. Yeah. Yeah.
That's because I'm mostly dead.
Yeah. Yeah. But it is very important though. Yeah. Yeah. I think it is. Yeah.
Sometimes don't even put the deck between the windows. You've got them.
Yeah. Yeah.
What's the cost?
Yes, yeah, that's it. So flashings are typically very cheap, but the materials are very cheap. But it's very important to get flashings correct and think about flashings and to be conservative when it comes to the design and the installation of flashings, because it's where many buildings fail in the moisture sense. So flashings could be made of copper, bitumen, coated metal, typically aluminium, or zinc coated steel, polythene, or lead, which was used in older buildings because it's a very, very malleable product. For obvious reasons, we don't like to use lead these days. So flashings at the base of the wall, so it can be used to replace DPC. So typically our DPC acts as a flashing as well at the base of the wall. Openings must extend 100 millimeters past the sides of the openings and extend across the cavity. So we'll typically over our window. So we've got our stud, our brickwork here like this. We've got a window happening in here. We'll have flashing, not visible, over top of our window. And that's carried back to our stud work, and then in elevation view, so that's our window here, we carry our flashing 100 millimeters past the edge of the window, because we want to ensure that any bits of moisture that land here and get blown inside don't want to go inside the wall. They'll travel back out again, or any moisture coming down the inside face. Carried out. So must turn up 150 millimeters and be fixed to the timber frame. Parapet flashings are very important. Or if you're designing parapets, to think about how the flashing is going to happen. I much prefer this detail as opposed to this one. So this detail, we have a flashing going through the cavity brickwork, and the flashing is directing moisture to the external face of the wall. That causes aesthetic issues, in that you typically get black mould happening, primarily on rendered surfaces, but also on brickwork. There, you get unsightly marks from that moisture if you're getting a decent amount of moisture coming through here. Whereas with this detail, if you get moisture coming through cavity into your parapet wall, it's carried out onto the roof. So, of course, flashings must always overlap against the direction of the flow of water. So you have to think about that. So So we get our roof laid first, then this flashing goes in, and then that flashing may be installed initially, but then that's bent over. We don't want to have a scenario whereby this flashing goes on the inside of that one, for example, because it's all about ensuring that moisture flows downhill and the overlaps face the opposite direction.
What is a parapet?
Oh, parapet, that is where you have a wall that extends past the roof line. Typically, yeah, there might be some parapet walls on these designs.
Like a chimney thing as well.
No, I suppose
That's
it's a bit higher than like basically where your gutter line is. So basically, it's when it's have you seen many houses like newer houses these days where you just see basically the wall continues straight up?
Yeah.
Basically, the roof comes in behind it, and that's where your box gutter is, and it exits the water that way. That part where it is a bit higher is called a parapet.
Alright.
You don't see the snowy exercise.
See like the last one that's not look more like the parapet.
Depending on the
Yeah, see the one there and the one on the back. That one and the last one there. Yeah,
Oh, this one here?
Yeah.
Yeah.
more like parapet.
Well spotted, yeah. So that one will have a roof sunken down behind that parapet wall there.
And it doesn't matter the direction of the roof, like whether it's going down or up, or
Yeah.
it's always called a parapet.
Yeah, well, typically, actually, probably the most common use of parapet walling is for retail facades or for shops and for buildings where you want to have a large presence and signage on the front. So if you drive down a main road, you'll see lots of buildings with flat facades like this, and then and the top is just level. That's, in the vast majority of cases, that's going to be a parapet wall. So this is our shop front here. So there's our street, foot parking, etc. That's our shop front there. And typically you have a parapet wall. Now you may have a roof which slopes back like that, and a roof here like this, for example, and then probably at the back no parapet because no one's looking at that. And so you have this parapet there for aesthetics and for signage. And so here you're going to have a box gutter or a parapet gutter on the back of that, where you've got a roof sloping towards it. And that box gutter, there's an Australian standard for designing the size of that box gutter as well. And that Australian standard also governs how that gutter can be designed. You can have a box.
how high it has to be.
Yes.
Everything.
Yeah, everything.
Basically, square meterage of basically the roof.
Yeah, and the rainfall intensity of the area. But yeah, basically with your box gutters, like your flashings, it's best to be conservative, make it much larger than what you really need, and also have a larger slope on there than what you really need. And so that's your typical parapet detail. However, at times you'll have a parapet wall like that, and then you have your roof slope away from your parapet wall. So in that scenario, what we need to do is have a parapet capping there, and then we have a flashing under that parapet capping that goes onto the roof like that to ensure that no moisture gets into there. So that's far simpler detail. And also behind that, so this is our shop front here. Sometimes you might have a roof behind it that looks like that as well. Same sort of deal. You got your parapet there, and you got your parapet flashing behind that to your roof.
You need a better white wall.
Yeah.
Hard to see.
Yeah, all right. I'll
The green one.
red. Oh, we've got black or red.
I think black.
Black. All right.
It's just hard to see from back
Yeah. Okay.
That's the lights.
So openings in masonry, because masonry is heavy and with independent units, we need to provide a lintel underneath that masonry. So for a single leaf wall without a very wide opening, we may be able to get away with a flat bar lintel. However, typically over our openings we have to use a steel angle. And there are manufacturers or Prida manufacture the lintels, and they specify what openings they will span. So that's the galvanised lintels. Minimum bearing areas for lintels opening is typically 100 millimetres. So you carry your lintel 100 millimetres past the width of your opening. Garage openings, so we're talking about large spans, possibly up to 6 metres. Use a T-bar lintel or a welded steel beam. So these are our various different types of lintel and how they're built into the brickwork. So that's a T-bar lintel there. And this is an interesting detail where we've got an I-beam that carries the load over the opening, like carries the load of the preformed concrete floor over the opening, and then there's a, I guess this is some form of lintel for the brickwork that also operates as flashing. So examples of your lintels. So as designers, you won't design them; they'll be their proprietary product, and the supplier specifies their thickness, and their spanning capabilities. Here's an extract showing the placement, the typical placement of lintels for your various different types of roofs. Which supplier, whose product literature this is, I don't know, but just as an example. So for construction type A, your standard brick veneer house. Where are we? That's construction type A. Your 90 by 6 millimetre thick equal angle can span 3.01 metres. So it can do a 3 metre opening, basically. So yeah, and these are your larger. So you've got the larger forms of lintels. So the EA, that stands for equal angle. And UA, that stands for unequal angle. So equal angle is where we've got, so it's 90 by 90. Your unequal angle, we've got one at 150 and 90. And also in that table down the bottom there, you've got your flat bars as well. So that's for 75 millimetre wide flat bar that's 8 millimetres thick in construction type A can span 490 millimetres. Or construction type B, so our cavity brickwork can span 250 millimetres. So that's fairly useless for that type of construction because you're not getting many openings of 250 millimetres or less. So that's it for masonry. Well, that. What I've also I should move that one out of the way. Okay. So what I've also done, grab a few internet resources. Show you what resources are at your fingertips for your various different cladding options as well. So we've covered masonry. Wood solutions is a very good resource for pretty much all things timber, but they've got a section on external cladding. So external cladding is typically going to be hardwood cladding, so we need to use a timber which is going to be durable. Also, when we use timber as an external cladding, we have to be cognizant of what the fire resistance needs to be as well. And so for building in bushfire prone areas, that's Australian Standard 3959, it's got a table there called Table F, and that tells us which types of timber we're allowed to use in bushfire prone areas, either as external cladding or for window and door openings and architraves, etc. So there's, so here we go, durability and grade, where timber clad walls will experience moderate to severe weather exposure. Cladding manufactured from the highest available grade of timber should be specified. Australian Standard 2796. Timber hardwood sets out details of grade, descriptions, machining grades, limits and tolerances, etc. for external cladding. So there are various suppliers of hardwood cladding, and they also give you your fixing details, which is important to adhere to for your timber cladding. Some good details in regards to fixing timber cladding are to have your slope. So we've got our timber frame like this, and then we have our battens. To have a slope, well, I'll accentuate that so we can see it a bit clearer. But a sloped top to your battens, and then your external cladding is fixed. Let's say we do vertical timber cladding, it's fixed to that, so any moisture gets in here, hits those battens, and goes back out towards the cladding. Traditionally, the most common use of timber as cladding has been as shiplap boards, so horizontally laid boards. However, it's it's not a popular thing, but it's a very aesthetically pleasing and very modern way of using timber is vertical. So you have vertical hardwood cladding like this, and they're cut in a fashion to overlap, so to create laps and allow some expansion and contraction of timber. Durability and grade, touches on that. Sizes and profiles. So once again, it's important as the designer to think about your placement and size of openings. So do that in accordance with the size of the timber cladding. So this is in regards to your horizontal. So timber cladding is generally produced from 150 millimeters to 200 millimeter wide boards. Anything wider than that increases the risk of cupping or splitting. Alternatives to solid timber cladding, plywood cladding. So plywood cladding offers a stylish exterior for all building types. Exterior plywood cladding is manufactured to Australian Standard 2271 and is intended for use in non-structural applications. Comes in a wide variety of base veneer grades. Issues with plywood cladding are maintenance and having to sand and reseal the plywood to ensure that it keeps its aesthetics, but then also doesn't degrade over time. And as I mentioned before, your table F in Australian Standard 3959 sets out the species of timber that you can use in bushfire prone areas. So some of those species are, just from memory, blackbutt, spotted gum, I think tallow wood as well, you can use in bushfire prone areas. But things like Western red cedar, you can't. Certainly wouldn't use white cypress. So anything on here that people see that they want to have a quick look at? Basically, have a look at installation details. So it has some installation details showing the location of flashing and external and finishes to external corners and re-entry corners. So that's a good resource for any questions about timber cladding. Typically in Adelaide, we don't have a huge range. Well, we don't have nearly the range of options for external cladding as what you get
Victoria.
in places like Melbourne. What's that?
Like Victoria.
Yeah, like Victoria. But if you want to stay cutting edge, or you want to be getting those more innovative architectural products, Victoria is a good place to look because they're. What's that?
Feel free to pay for the nose.
Yeah, well, you have to have it. Yeah, have it delivered. But it's certainly worth exploring because you don't always have to pay for the nose for everything
You can
as
get
well.
Western red cedar, which isn't a hardwood, but it's very aesthetically pleasing. It's just you get that from Victoria. You can get cedar in particular from Queensland, but again, I think from the cedar just on delivery from Queensland, you're looking at at least $400 or $500 just for delivery. Yeah. To get it from there down to the wholesaler in Adelaide, and then they get it delivered to you. So.
Yeah. And that $400 or $500, that depends on the volumes as well.
Yeah, exactly right. I mean, depending on how big, what sort of space you're looking to do. I know there was one company that I used to deal with that wanted nothing but something from cedar sales in Queensland, and they only wanted maybe 100 million metres worth.
Right, so hardly anything. Very small batch.
Yeah, I said no. It's going to cost you this, or it's going to be we have to machine something up similar. No, we want that one. Good luck. Yeah. You're going to pay for it then.
Yeah.
Simple as that.
Yeah, and certainly cartage and transport of materials is definitely a major consideration in the cost. So if you can find
even noted of that as well. Particular companies do have particular profiles they use. Yeah. And something as simple as, the issue we had was the castellation, which is basically, it was 86 by 32, and it's just had a particular, three basically upstand mould out of it to give it a certain look. Yes, yeah. And to get, which I haven't tried to source it from a local supplier, they had a slightly different profile, which wasn't good enough for this client. So, and we couldn't go to another company like a wood machinist to be able to
create a
profile because it had a copyright on it. So, but I ended up sending the actual profile to the company and to the wood machinist, and they said, no, copyright profile, can't touch it. Right. So,
So in that instance, it had to be imported from interstate from the supplier.
Eventually, he said, "No worries, we'll get it from the local one." I'm like, "It's cool." So we sell $500.
And it is a very good point that the transport of these materials can be very expensive. But I think also it's good to keep your eye on what is happening in Melbourne and Sydney and what products are being used there, because there is a lot more high-end building which is happening there.
Depending on what products you get, they can be involved with a wholesaler in Adelaide, of which if they are, then you can get away from not getting charged delivery fees from, particularly Victoria in this case, over to South Australia. Because generally they'll have trucks come over every week. Chucking. 100, 200, 300 millimetres worth of a truck is quite little compared to having to get a whole semi to be able to deliver.
Yeah. But this group, CSP Architectural, I found quite a good resource for some of your more innovative, well, architectural in inverted commas claddings. So
what about getting from overseas?
that's something I haven't looked into, but I think yeah, you might.
What local?
Yeah, support local, yeah.
Oh, look, I'd love to support local, but local doesn't support me, so.
Probably
They
that is
don't-
half, probably that is half the southeast is sold overseas.
Because you go to Europe, and there's so much you can bring here to this country, where our isolation has allowed us to not evolve the way we should.
So yeah, with bringing things from overseas for some things that are compliance issues,
Of course,
which you're well aware of.
Australian standard to fall back to.
Yeah, and whether those materials are being tested. So like a really hot topic at the moment are your aluminium sandwich panels.
I
yeah.
wouldn't use anything that's Chinese made
Yeah,
or certified by some Chinese laboratory, so it's
They wouldn't,
compliant to
they
Australian
pretty much
code.
wouldn't pass Australian standards. Australian standards are actually pretty high compared to the rest of the world.
They are high, I know, but then you've got some Chinese companies that do Australian standard testing. How would you trust them?
That's the up to the interview.
yeah,
And
and
they give you a certificate that says, look, pass the Australian standard by X, Y, Z.
On the other hand, you look at formwork pipe for one. Form pipe for one, or marine pipe. Its import product is $80 a sheet. Get it from us, get Australians one is 180.
so significant savings by direct. Yeah, but also issues in that. So yes, whether it has Australian, or whether it has certification, but also who's carrying that certification and whether that company are going to exist later on when you found the building product has failed as well. So so if you can get something through a local supplier who's going to carry that certification, then that's fantastic.
Our windows and openings that we use in this country are so substandard to what you can get overseas. It's worth laughing at.
Yeah.
Correct? Tell me, you come from a cold climate.
The house here are a bit wonky.
Yes. Yeah.
Wonky.
Yeah.
What about the windows?
Yeah.
We can do a lot better.
A lot.
Yeah.
And then you try and bring something from overseas.
I know. We thought our windows weren't up to standard. We checked 3 times with the builders, and now this is the minimum standard. And
Yeah.
I'm surprised they still didn't fall out of it.
And again, it's a protected industry. Try and break it. It's
Just last fun.
But yeah, back to cladding. So
glass is fun. Yeah, there's glass.
yeah. So back
Don't get me started.
yeah, back to cladding. I found this company over in Victoria produce a good website. They're a good resource. And so maybe now is that for the drop down one? No, it's not the drop down one. Of click on products. Yeah. So version products. Alpolic, so it's a aluminium sandwich panel cladding. Ecotone was speaking about fibre cement sheet cladding. So you've got your standard sort of fibre cement sheet claddings, but then you've got companies or products like this that producing I guess how to say it, far more interesting cladding options with fibre cement sheeting. So the various different colours and finishes. So
You may go up to somebody who's building a house in Adelaide saying we can use this product for your house, not all over. So when you try and sell it, they reckon the other bricks.
Well, and that
That's the problem.
may be not 100% the case, but also I think look, it's if you are aware of these products, you are aware of the cost of these products, you know how to work with them, details and so on required. I think that's
dealing with someone that's willing to have
that's great.
such a vast architecturally round house. They've probably got a bit of coin about throw it as well.
Yeah,
They're willing to spend that much money on an architectural plan, then
so there are people doing some very interesting stuff with cement sheet cladding.
Is that all locally made?
I think it's European.
It's closed.
James Hardy's locally made.
Yeah, James Hardy's locally made. There are some ethical issues with James Hardy as well, or with the company. But yes, so and we. Yeah. Oh, okay.
We'll leave that alone.
Yeah.
There's a few there.
Yeah. So and yeah. Vitro panel.
Oh wow.
That another fibre cement sheet. So trying to think of the name of the up in on Lower Northeast Road. There's a swimming centre that's just been the ARC just been built there. They used vitro panel for their external facade. That's where I first noticed it. Wow, that's really interesting stuff. So basically, it's fibre cement sheet cladding with a hard surface. How do I say it? A very very smooth surface on the outside that comes in many different colours, so you can get that that really bright sheen to it. It looks similar to aluminium cladding.
A Lucabond.
Yeah, a Lucabond looks it looks similar to a Lucabond. But yeah, that and James Hardy. So once again, a producer of compressed fibre cement sheet cladding, but also various different other forms.
I'm trying to avoid James Hardy. There is BDC, which are doing pretty much exactly the same products as James Hardy. They're just altering a couple of little things, just so they're not.
So it's not copyright. Yeah. So BDC, are they a local? Are they an Adelaide manufacturer?
They're all over Australia. I know that.
Yeah.
But, they do have a couple places in South Australia. They're trying to get in bed with Rivergum at the moment.
Right.
I
Yeah.
think they've got most Rivergum jobs at the moment.
Yeah.
The boss is trying to start doing a little take off because they're paying some bloke in Tasmania $250,000 a year just to do take offs in Australian furniture.
We'll have a look at that. Yeah. We'll have a look at BDC in a minute. Yeah. So Hardy's are doing some of the more, well, I guess exotech. So that's a thick fibre cement sheet for this expressed joint look. So competing with those other more architectural forms of cladding. However, they do a lot of your traditional fibre cement sheet cladding profiles as well.
Is that Sky? Is that
Yes, yeah. So your various different profiles of scion. So that one's Stria.
Is there a way to find out the environmentally friendly properties of these products?
There
It's hard.
WeatherTex, which is basically pressed wood chips, similar to what your masonite and so forth was. They do have particular profiles as well, probably as well, WeatherTex.
Yeah. Okay.
Which you can. Well, I used to have a friend who worked at cook houses in Eco Village, and everything down there had to be eco-friendly. So
Yeah.
we use that and a few other bits and pieces like that.
Yeah. But in regards to getting the information on how environmentally friendly the products are, it is hard to get that information. Obviously, product suppliers, well, there's for want of a better term, there's greenwashing that happens across just about everything, and so products are promoted as being environmentally friendly, but you do need to look into the background and say, okay, what underpins that claim of environmental friendliness, and what
WeatherTech is part of like the forestry industry, so they've all got all the signed off, everything else, and so they are manufacturing it in a more in a safer way in particular. And it is recycled timber, so it is much better for the environment as opposed to parties, fibre cement.
So because there's a certain amount of embodied energy plus various different
resources.
Whereas
Whereas timber is basically just carbon. You can regrow it. It's renewable.
It's a carbon store. So once it's great. What's that? Well, to some people, and that is. So various different drivers of design.
I moved into a brand new house and it made me really sick because of what it was built out of.
Yeah.
So that's just kind of why I ask as well, like with the environmentally friendly sort of.
It could be environmentally friendly but still make you sick because they've had to do certain things.
There's chemicals in it and everything.
Now we're doing a renovation on a house and we're using like non-toxic products. But I want to look after the environment at the same time as well.
Yes.
And look after my body. So that's kind of why I asked the question.
And it is important to do your research on that. It can be hard to find out this information, and you've got building product manufacturers that have produced harmful products knowingly for times, and then
back to the ethical thing again. Here we go.
and so there are motivations for not wanting to make that information public, and so it can be hard to find. But then there are also product producers that make it their thing of producing products that do have like low volatile organic compounds and that are that are safe to cut and so on. So
the sad thing is the consumer wants cheap. That's the problem. Cheap. So these people who are trying to do the right thing go out of business because nobody wants to use their product. Because it's a fantastic product. It's too expensive.
I know it only like 2% of people who would use it.
That's what kills it. And 2% of people won't sustain those businesses. And that's what as much as we all want to do it ethically correct, the dollars more powerful.
So typically from a developer sense, where you as the client are not connected with the building process. However, if you are employing an architect, building designer, if you are connected with the building process, then and a student client, let's say a student client, then certainly a lot of these products are available, and that's also a point of difference you can have as a building designer as well, and say, look, I have a lot of knowledge about healthy homes, about what materials off gas, etc. And what is greenwashing and what are actual environmental credentials. But it does take a little bit of digging, and there's I can't point you to any one resource.
If you do it for yourself, you can do it. It's sustainable to do it. But if you're going to find out, trying to pump out this work, they're not going to pay you for the research that you've done.
No.
They say, what results got such a black and white on a piece of paper. That's what they see.
Yeah.
So you've got to see yourself as an interior designer, as a product selector. It's not just a drafter. It's a whole. And then you get a bunch of specialised deliveries that be with you. They don't want to know you until you get this name, and then when you're famous all of a sudden, your name different.
But it can be your biggest point of difference.
Just a reality.
And so various different, so they're producing various different profiles, etc. as well. Another thing I haven't shown Well, we've got the sheet sizes, which is an important thing to consider for your window placements, etc. But typically with all your suppliers, they want to make it as easy as possible for you as a building designer to specify their products. And so typically they will have a lot of what you need located somewhere on their website. So technical supplements, if you want to use some fibre cement sheet for bracing board, the technical supplements for that, bushfire information, material safety data sheets, installation details in a PDF form. Let's have a quick look at that. So installation information. So it's not just the details, but yeah, where are our? Yeah, that's what I want to see as well. That's what I was. Yeah, that's what I was hoping to find on here. An example of.
Get it from the Hardy's website.
Yes.
Sale.com.au.
Yeah.
Because if you use Revit, for example, it's a lot easier to download a big wall rather than to try and build it. So
I was hoping we'd find the CAD details here on this link as well. But typically for many of these suppliers, they'll also supply you with the CAD details. So another interesting external cladding option, inner wood. So it's a manufactured wood, so composite timber product made of 70% of wood waste, material eco-friendly, so use it, have a look at that. And is recyclable with high utilisation of waste timber, low carbon footprint, etc. So yeah, you see inner wood used a lot for decking, but I've also seen it used for external facades, and actually I thought it looks quite nice, and it's dimensionally stable. Various different colours and finishes.
I dispute the look.
What's that?
Dispute the look.
You,
I like that.
yeah.
My opinion, but
Yeah, your opinion. Yeah, well, look, it depends what it's used for. But yeah,
what you're going for.
Yes,
It's the same as like in mod wood and so forth that you get for like your decking and all that crap. I've had a client come in and go, I want mod wood. I'm like, yeah, no, you don't. And they wanted the Jarrah colour mod wood, and I've gone, look, I took her to show her the difference of the mod wood and actual Jarrah, and she's just blown away by how much of a difference it is. Now that's still depending on whether or not you're willing to do the work and so forth to look after your timber deck and all this other stuff. If I've said if you're going to put in your own house, you'll go the solid timber. But if you're doing like for a rental or anything else where you know that someone's not going to put the attention and detail into it, go
your low maintenance options. Yeah, and things. So I think with these imitation products, I think it's generally from an architectural perspective or design perspective, it's not good to use them so much as a replacement, like to think that I'll fool people to think that that's actually timber, because by and large the vast majority of people can see, okay, well that's not real timber. But I saw it used to really good effect just on a small toilet block. So the design of this toilet block, it's not a large space, and this vertical cladding of inner wood on top of fibre cement sheet cladding, which I think was painted black, so you had expressed joints, actually looked really cool. And it's very very durable, but interesting aesthetic. But I think the design of that toilet block was not to say this is wood, but that and I think in this sort of situation as well, it works quite nicely as well. There are
but if you look at it, if you try to compare it to solid apples and oranges,
very very different aesthetic. Also got a link here to Keystone. So they're a company that do what do you call it, routering of all your various different products and so on for creating acoustic boards. So for for plywood, fibre cement sheet, etc. See if they've got some examples down there. So acoustics for that, but then that may typically used for internals, but you may want to. That may be an idea for cladding as well, in various different scenarios. There's external use of some of them. I think probably they routed these fibre cement sheet portions. Okay, well, it's something I'm not familiar with. Whatever that one is. Sorry, I'm not actually familiar
So
with.
it's a cement.
Yeah, fibre cement sheet.
Yeah.
Yeah.
Composite.
So, yeah. So once again, I think of another. Oh, it's an interesting surface for the cement sheet, isn't it? And Pro mat. Oh, it's right, acrylic seal. Alright, try to get rid of this dude. Well, stop presenting it. Actually, while we're going through all these things,